All right, so here at the beginning of Unit 4, we're going to start talking about covalent nomenclature. And remember, this is the rules for how to name and write formulas for covalent compounds only. We've got completely separate rules for different types of compounds. So if you haven't already gone through and figured out how to tell each type apart, that's a good first step. But this is going to cover pages 3 and 4. It's just the last little bit of 3 that we didn't cover, and then 4 is mostly practice. And technically page 5 is the practice that goes along with this. So if you missed class, you didn't get these notes in class, you might consider trying to do some of that practice on page 5 as well. But starting here kind of in the middle of page 3, remember that covalent bonds form between 2 or more non-metals. And because their electronegativity differences are very low, they're pretty similar electronegativities, they share electrons. They're about equally strong in that covalent bond. So the same 2 elements can form compounds with many different formulas. For example, CO2 is carbon dioxide, carbon and oxygen. And carbon and oxygen can also form carbon monoxide, where we just have one oxygen there with that carbon. So the same elements can get together in different ratios, which is why we're going to have to use prefixes, words to tell us how many of each element we've got. Like the di in dioxide means 2, the mono in monoxide means 1. It tells us exactly how many of our elements we have in that compound. But we're going to get to some of those fancy rules here in a minute. What we're going to start with is some common molecules that don't actually need to follow those fancy rules. And the first one is ammonia. It's a common cleaner around the house. You've probably used it before even without knowing it. It's the active ingredient in Windex. And even though it has a fancy schmancy science name, nitrogen trihydride, a lot of times people are just going to use its common name because it is such a common covalent compound. So you do need to be able to recognize that name if you see it. It's not something that I'm going to put on a test just to quiz you on, but it is something the district people like to use. They just say ammonia, they don't tell you it's NH3, and that's not really its normal scientific name. So the rest of these 7 things that have some common names you need to be familiar with are actually some special types of compounds called diatomics. And we've already kind of mentioned diatomics briefly in the first chunk of notes from this unit. Because they're the only ones with a 0 electronegativity difference, because they're the same atom bonded to another atom of the same type. That's where the name diatomic comes from, 2 atoms of the same type bonded together. And so these, out of all 118 elements on the periodic table, there's only 7 that form these diatomic molecules, and you need to be able to recognize these 7. Now their name or formula is already written out for you down below, but to help you kind of remember them, I have 2 different mnemonic devices that might help. The first one is kind of a weird, random seeming sentence. I bring clay for our new house. But this sentence, the first letter or letters of each word is the element symbol for one of these 7 diatomics that we have down here. So iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Another mnemonic device, tip for remembering them, it's a little bit shorter, but it's also a little bit more nonsensical. It's the word Brinkelhoff. It's kind of a fun word to say. It kind of reminds me of Hasselhoff, but it's still just a word made from those element symbols of those 7 diatomics, just in a slightly different order than that first statement. So, one way or the other, you need to know these. There will be a question on the test that literally just asks which of the following elements either is or is not a diatomic, and you've just got to know them. So start working on that now, and it'll be extra easy later on. What I want to reinforce here as we start talking about these diatomics, even before we have them memorized, is that as these are elements that exist in pairs, that they're never going to be all on their own, they're just known to be in these pairs. We don't have to incorporate anything special into their name because of it. So when we're talking about Cl2, even though later on we are going to get a prefix for 2, it's di, we're not going to call this dichlorine. It's just normal old chlorine. Because all chlorine, if it's pure chlorine with no other elements in there, is going to be sets of 2 chlorine atoms connected to each other. Similarly, F2 is just fluorine. Br2 is bromine. I2 is just iodine. That's the way these atoms exist in nature, just naturally on their own. They're going to exist in these pairs. And kind of conversely, if we're talking about cellular respiration and the fact that we breathe in oxygen molecules into our lungs, it's not individual O's going into our lungs. It's sets of O's, sets of pairs of oxygen atoms bonded to each other. It's always O2 that we're breathing in, turning into CO2. Similarly, hydrogen gas is H2, nitrogen, N2. We don't have to put anything special. Sorry, I'm getting too far. We don't have to put anything special in their names. We just name the element because that's the way the element exists in this pair. Now at the bottom of the page is some more stuff that we've just got to memorize. And these are those prefixes I was already talking about. A lot of these are probably a little bit familiar to you, like the di and dioxide. That means two. We just have to remember that we're not using bi. That's used in other situations for two, not in chemistry. Mono is probably not as common as many of them, but you've probably heard of a monorail. It's a train that runs on one rail. Or a monocle is like glasses, but it's only one lens there. Tri for tricycle, a bike with 3 wheels, or triplets has that tri prefix there. Tetra is another kind of weird one. Tetra is 4. You might think it's quad, but quad is more geometry, and we use tetra here. And probably the only place you've ever heard or seen tetra mean 4 before is with Tetris. All of the different shapes, if you're playing Tetris, you're trying to get them all to fit in with each other, and each of those shapes, even though they're all different, are all made out of sets of 4 blocks together. So that's why it's called Tetris, and that's why tetra is 4. Penta and hexa are really just common geometry terms for 5 and 6. Hepta is used in geometry sometimes, heptagons. You just don't draw that many 7-sided shapes in geometry. Octa is 8, nona is 9. Once again, it is the correct prefix you would use for a 9-sided shape, a nonagon. You just probably don't draw that many of them in that in geometry. And then a decagon, 10-sided shape, or a decade, sets of 10 years, pretty common prefix there. So even if you don't know these now, make yourself some flashcards or practice one way or the other. You got to have them memorized by the time we get to the test because you're going to be writing lots of different names with these prefixes in them. So on the next page, we're actually going to get into the instructions, the steps for putting together a covalent compound name. And the first 2 steps, which we've bolded, are really the most important. We're going to put a prefix before the name of each element to tell us how many of that element we have in that compound. And the only other thing that we have to do is change the second element's name to have an "ide" ending on it. So we're going to cut off part of that second element's name, change it to "ide." It's kind of like when people get together. They get married, they change their last name a little bit. That is true for our elements as well. Put the elements together into a compound, the last name changes. Doesn't become a new element, doesn't change as completely as a person's last name does, but we do have it change its form into its "ide" form. Not that you need to write these down, but I do want to make sure that you're familiar with them enough to be able to use these names and kind of change these names. So I want to go through them. This is all the nonmetals we have. It doesn't take that long. For the most part, you're taking the first syllable of the original element's name, dropping the last syllable or 2, and adding "ide" to it. So with hydrogen, our first syllable is kind of that hydra there. So we're taking the hydra and adding "ide" turns into hydride. Boron changes to boride. Carbon changes to carbide. Nitrogen changes to nitride. We're just taking that first syllable and adding "ide" to the end of it. Oxygen, oxide. Fluorine, fluoride, like the stuff they put on your teeth at the dentist's office. Phosphorus, phosphide. Sulfur, sulfide. Chlorine, chloride. Bromine, bromide. Iodine, iodide. And for the most part, those are the nonmetals you're going to see in a lot of the common covalent compounds. Technically, we do have 4 more nonmetals over here, but these you're probably never going to actually see or need to change into their "ide" form. But silicones would turn into silicide. Selenium would be selenide. Tellurium would be telluride. and astatine would be astatide. So they all just take that first syllable, sometimes two in weird situations, and then add that "ide" to the end. So that's what we're going to be doing. Prefix, element, and change that last name to have that "ide" version. Now, there's a couple other little notes, and honestly, 3 and 5 are the same, and they're not really that important. This is not something I'm going to do a lot of, but especially if you do practice online or from other sources other than my packet and my answer keys, you might see this happen, and I don't want it to confuse you. If we have two vowels in a row from the prefix and the element name, like octo, oxide, a lot of people will drop that repeat vowel so that it's just octoxide, because it just sounds a little bit better. It flows a little bit better. But they don't always drop the repeat vowel, and it's not always just if they're the same vowel or if they're different vowels, they keep them or drop them. It's weird, and it's not very consistent. So I tend to just write my prefix and my element name. I don't drop any extra vowels, even if it sounds weird. It's just easier to leave it normal. If you, like I said, you go outside to do some extra practice or checking some answers, you might see that happen, and that's why. Step 4, though, or kind of instruction number 4, is super important, and I've highlighted it here. We are never going to use the prefix mono on the first element. So we cannot put mono as this first prefix here. Not allowed. But you can use mono, and that's really the only time you would use it, if it's on the second element here. That's fine, perfectly acceptable if you have one of that second element. But if it's just the first element that you have one of, you're just going to name the element. Just leave off the prefix completely, like carbon dioxide. We don't call it monocarbon dioxide, even though we do have just one carbon there. Just a lot of compounds start with a single element, so we don't want every single compound to start with the word mono. So let's do some practice here. We're going to start with the names and turn them into formulas, and this means we're just decoding what we see there in front of us. Carbon is C. Disulfide, remember that prefix di means two, so I have two sulfides, and sulfide is just the "ide" version of sulfur, which is just S. So to show that we have two sulfurs there, we put the 2 after the S. Honestly, that's the weirdest thing about this, is that the prefix becomes a subscript after the element symbol, even though the prefix started before the element's name. So sulfur trioxide is our next one. Sulfur is S. Trioxide means I have 3 oxide, 3 O's, so that becomes SO3. Diphosphorus, here we have a prefix on that first element. It's fine as long as it's not mono. Diphosphorus means we have 2 phosphorus atoms. Trioxide, just like in the last one, means we have 3 oxygen atoms, so O3. Next one, carbon is C. Don't worry about the fact that there's no prefix. If it says carbon, you've got to write down a C. And the only prefix we could leave off is the 1, and we don't write 1s in our formulas anyway, so we can leave that off. Tetra means 4, so we've got 4 chlorides, so Cl for chloride, making that a 4 there. Dinitrogen, sorry about that. Nitrogen is N. Dinitrogen means we have 2 of them. Pentoxide, pent means 5, so I have 5 oxygens here. Number 6 is very similar. It still starts with dinitrogen, so we're still starting with N2, but then this is trioxide, so we have 3 O's. Another example of the same elements making compounds with different ratios, different numbers in them. That's why we have to use these prefixes, because both of those are perfectly legitimate, stable compounds. Trisulfur, I have 3 sulfurs. Non-oxide, non means 9, so I have 9 oxygens, so O9. Iodine is I. Mono means 1, so I have 1 bromine going with that iodine, so just IBR. We don't write ones. Even when we see the mono prefix there, we don't write any ones in our subscripts. Then tetrasulfur. I know this one is up at the top of the next column, but it's still part of our formula writing practice. Tetrasulfur means we have S4 to start things off with. Dinitride means two N's, two nitrogens. So hopefully writing formulas isn't too bad. It's really just decoding all of the fancy symbols and their prefixes for each element. But hopefully our element quizzes have had you practicing these, so it should be no big deal. Now let's move on to writing some names. And these are a little longer. In fact, I've made my lines a lot longer because I write pretty large on this screen. You're probably going to have to go off the lines that are already printed on your page for you there, but just do the best you can to get these names on there. For each of these, when we see that I have 3 P's, 3 phosphoruses, then I need to turn that into its prefix and element name. So 3 turns into tri. So triphosphorus. And then 8 oxygens, O8, turns into octa, and then oxide, making sure that oxygen turns into its ide version. And only the last element in our compound changes its name. Oxide is going to be a pretty common one there. Then this next one I have 2 carbons, so that becomes dicarbon. And then I have 6 sulfurs, so 6 is hexa. And sulfur changes into sulfide. Next I have 2 nitrogens, so that's going to be dinitrogen. And then I have 4 hydrogens. 4 is tetra. Hydrogen changes into hydride. Next one, I have 1 carbon, but I'm not going to call it monocarbon. If there's one of that first element, we just name the element. We do not put a prefix there. So just plain old carbon. Then I have 2 oxygens, so 2 is di. Oxygen changes into oxide. And a lot of you probably just saw that and were like, oh, CO2, carbon dioxide. It's a great one to remember in general because it has all of our rules in there. It has our prefixes, but not mono on the first element, changing to ide for that second element. All of the important rules to remember are all part of that classic compound, so a good one to remember. It's an iconic covalent compound. Next one starts with Cl2, so we have 2 chlorines, so 2 is di. Chlorine stays the same. And then we have 7 oxygens here. So 7 is hepta. Think of that as like hexa, but a little bit bigger. Hexa is shorter than hepta. And then oxygen is oxide at the end of our compound's name. Next one, 4 arsenic. 4 is tetra. And then we leave arsenic the same. And then we have 6 oxygens here. So 6 is hexa. And then, of course, changes to oxide like it always does. This next one is not just if, it is iodine and fluorine together, just one of each. Remember, we're not going to put a mono on the iodine, just name what we see. And then this next one, we have 1 fluorine there. And so this is where I'm going to have to use mono. And fluorine changes to fluoride. So hopefully that's not too bad. Just prefix element, change the last element's name to ide. Remember not to put mono on the first element, but if you do, that's not the biggest deal because, you know, just partial credit. But prefix element, ide. It's the general rule for these names. So on page 5, there is some practice. Like I said, if you've already been to class, you should have already done this. You might just be revisiting these notes before the test. If you missed these notes in class or are doing these when I'm not there, then this is your next order of business to do these practice problems here. There is a little itty-bitty issue on number 5. It should be Cl2, the first 5 on the page. It shouldn't be Cl4. Cl2 is just our diatomic chlorine molecule. It does not exist in sets of 4. So you should be able to check your answers with the answers that I have in class, or come in for tutorials and I'll help you with them if you need any help. And we'll work on ionic and some other compound naming in the future classes.